I'm Anil Kumar, and in these set of 3 videos, I'm going to review all the concepts which we have learned about trigonometric functions. So let us begin by understanding how to write equation of a sine function from the graph. So the question here is, determine sine and a cosine function that models the situation represented by the graph below. Now this type of graph you are going to see many times, especially in examples like Ferris wheel. Now here it starts with a minimum, goes to maximum, then ends with a minimum. To find the equation of a sinusoidal function, we should always begin by writing maximum and minimum values from the graph. So the maximum value you can read, that is 5 meters. So let me write just 5, we'll add units later on. And the minimum value here is 1, so that is the minimum value. Minimum value here is equals to 1. Now maximum and minimum values will give you amplitude and axis. So even before writing or finding those parameters, let me write down the function in general. In general, we'll write the function as f of x equals to a times, let me write sine first, sine k times x minus p plus q. So where a is the amplitude, k is number of periods in 2 pi, number of cycles in 2 pi, which is 2 pi by t, and q is the translation up and down. We always call it axis also of the graph, and p is the phase shift. So we have already got 2 values, which is maximum and minimum value. These values help us to find a and q. So a is equals to difference of these 2 values divided by 2. So the formula is maximum minus minimum divided by 2. So in our case maximum is 5, so we'll do 5 minus 1 divided by 2, which is 4 divided by 2 as 2. And q, the axis, right? So this is the amplitude, correct? Q, the axis, is the average value. Average means you add them up and then divide by 2. That also helps to remove the confusion at times. We get confused what to do with, they get mixed up, which one to subtract, which one to add. So take axis as average value, right? So we'll say average. So that will help you. Average is add all of them and then divide by the number of items. So here it is 5 plus 1 divided by 2, which is 6 divided by 2 as 3, and we call this as axis of our sinusoidal function. Now once you get this, it's good practice to sketch the average, which is the axis of the graph. It is at 3. So this is 2, this is 3. So let me just draw a dotted line here, which represents q for us. Now from here you can see that the graph goes 2 units up. So do you see this? 2 units. So that is the amplitude. Remember, amplitude is always an absolute value, right? So if you do the other way and get a negative value, you have to write absolute value, okay? That is very important. Axis could be positive or negative, but amplitude is always positive. Okay. These small things help you to understand the functions better. Now let's find the time period. So to find the time period, what we do is we need to find along the x-axis, in this case t is along the x-axis, 2 times when the graph is minimum or it is maximum. So that is what you're looking for. So to find time period, let me write down here. We have to find it is interval between consecutive maximums or minimums. Do you understand? So in this case we are given 2 minimums, we can use that, right? So that is the time period. So these are always the good points to look for. Now if in a graph you see only 1 maximum and 1 minimum, let us say we could have had that much of graph, up to 6 for example, in that case distance, the time between maximum and minimum you could find and then multiply by 2. Do you understand? So that is half the time period. So let me write down here, time period t is basically this distance. Right, so that is the time period. So time period for this particular graph is between two maximums, 8 minus 0. So which is 8 in seconds, correct? Now those units for amplitude, it is in meters, right? X is at 3 meters, correct? Now once you find the time period, then you can find the value of k. K is number of waves within 2 pi. So k is equals to 2 pi divided by time period, correct? So in this case, it will be 2 pi divided by 8, which will give us pi by 4. So k value is pi by 4, right? Now we come to a critical point where we need to find the phase shift, right? So in our expression, the function p value, the phase shift. Now for a cosine function, let's write cosine function first. Okay, for a cosine function, so let us consider cosine function. Now if you see how the cosine function is, let me sketch one here. The cosine function starts with the maximum, right? It's kind of like this. Now the given graph is from the minimum. So in this case, we could write minus cos. It's kind of a reflection, right? So it becomes minus cos, correct? So we can write this equation as, right here, as f of x equals to minus cos. So that is a good practice. So in that case, you can avoid writing, so p is 0. Actually, I should say half the time period. So p is actually half the time period. It's kind of like this. Do you see that? So that is where it is starting, but we could always think it as a reflection also, right? So minus cos can help you write the cosine function. Okay. Now what I will do here, since we have already found what the value of p is, in this case it is half the time period, right? But we could write this as a reflection, so we'll use transformation in this particular case. So what I can do is I can write down my equation in cosine. I'm running out of space also, that's the reason. So we'll write minus, so we have to write the value of A, amplitude. Amplitude is 2. So I'll write minus 2, 2 is for the amplitude, and then I'm writing cos, correct? And the k value is pi by 4, within bracket, x is my parameter. So here the x parameter is t, right? So I'll write t here, the independent value, and since we took p as a reflection, so that is it, and we have x is at 3, so we get plus 3. So that becomes the equation as a cosine function, right? Now let us see how to write this as a sine function. So actually I should have used function also as h of time, so we'll write h of t this time, right? So I should have used h of t here also. Okay, that is kind of important. When you're given a graph, you should respect what is given along its axis. Okay, so h of t is, let's see how to find phase shift for sine wave, correct? That's critical. Now if you analyze a sine wave, how will it look like? Let's draw one sine wave here. It is starting from the axis, right? And then it rises. So sine wave is starting from the axis and rising. So here you will observe that is the point from where it starts and rises. So that is the starting point for a sine wave. And it has been shifted 2 units to the right. That means P in this case is equal to 2, right? So in this case, P is equal to 2. So let me write down the equation directly. So we have amplitude of 2, sine function, k value same as we calculated, t, and p phase shift is 2 units, right? So that is from where the sine function starts, plus 3. So that is how you can write both sine and cosine function for the given graph, right? Let me give you alternate equation for cosine function also using the phase shift, which is here. The cosine function start from here also, right? So we could write this as also, let me write here, h of t equals to, amplitude is 2 for us, correct? Cos of k, we just calculated pi by 4, t minus, so this starting point for the cosine function is at 4, right? So we write 4 here, bracket close, plus the axis, which is 3, plus 3, correct? So that becomes the cosine function also. Both are equal, okay? So both are cosine function. But in any case, it is kind of important to appreciate that we could actually write our equation two different forms for the cosine function. Similarly, you can also write for the sine function, okay? I hope this example helps you to model the situation from the given graph. In the following two videos, we will consider average rate of change and instantaneous rate of change for the given function. And I hope with these three videos, you will learn a lot about the trigonometric functions. Thank you and all the best.